So let's talk about the communication protocol. That means when you from your device or your computer or server, they want to talk or send or receive any kind of messages, maybe from your laptop. You want to access particular website or social media platform. You want to send photo. You want to send text message. You want to watch the video. Any kind of excuse me, maybe from your mobile, maybe from your WhatsApp, maybe from your email, maybe from your particular server. Means nowadays we are using a couple of device. Maybe you talk about your mobile, you talk about the desktop, you talk about the laptop, you talk about the server. So finally, these devices, they need to talk, they need to communicate to send or receive data. Data can be text, data can be audio, data can be video, data can be game, anything. So for that we need communication, talk. So how this communication happen? So for that, there are lots of communication protocols. Protocols means the rules or regulation through which one device are communicated to another device. So today we are going to talk very commonly used protocol. Almost these protocols are heavily used the communication between the electronics devices. One is the TCP, another is the UDP. Lots of communication protocol in the one class we have talked in details the different types of protocol, different communications, synchronous, asynchronous, unidirectional, bidirectional, right? So today our objective we have to understand the TCP and UDP. So these are the two most commonly used protocols. Excuse me. So about the TCP. So TCP, you can say Transmission Control Protocol. It is a transport layer protocol. You already know in our computer systems we have a OSI model where we have a different layers of protocol like your application layer, session layer, transport layer, IP layer, physical layer, right? Data communication layer. So these TCP layer is part, yeah, work as a transport layer, and this TCP provide the reliable connection-oriented communications between the two devices, maybe phone, maybe computer, maybe server over the internet. Okay, the TCP provide the reliable and connection oriented communication. That means they are TCP ensure that data is delivered in the correct order without duplications or loss and provide error checking mechanisms to guarantee reliable data transfer. So where between your server or between your client, you want to exchange data, send data or receive data, and the data, the information you want to send or receive, you want it must be transferred. Okay, so must be received by the server because this is very important or critical data for me. I cannot say that this could be lost or this could be tampered. So this scenario where your data is very important, you want to ensure that the data is must from, if I'm sending, you must be received. So we are using this TCP protocol to make the communication happen between the devices. So these are the some basics terms, the concept we should aware, like what do you mean by the TCP sec, they provide the connection oriented. What do you mean by connection oriented? So TCP establish a connection between the sender and receiver before sending a data. So that means ki whatever the our client, whatever the client they want to communicate with the server or machine or laptop right now. So first, this protocol say I am going to make one connection between the sender and receiver. That is the dedicated connection between the server and receiver. Within this, we are going to send your data to the customer from to the server. So this is the one, this connection maintained throughout the communication session. So that means this connection will not go to the close. Let's say this is the sender send the data. Okay, sender send the data, receiver receive, again server response, okay or failure, again send the data, again the receiver response, again send the data. So this communication connection is still uh, not going to disclose until all the communication happen. That means ki whatever the communication between sender and receiver happen, this connection between the devices are established. And the second point about the reliability, what do you mean by that? TCP ensure that data is delivered in a order, correct order, without the duplicate or loss. That means whenever a sender want to send a big file, not just hello message, hi message, maybe some big file, or maybe some audio or some video, some text document. So generally the data is not transferred as a whole in the one chunk. So what the concept is that your files are distributed in a different small packeted small chunk a byte are minimum bytes. So first bytes they are going to send, then receive the next byte going to send, the next byte going to this. They are ensuring that your data are fully transferred here received by the server, and similarly the same order, what order they are splitted, the what byte they are read, and the same byte by byte data are transferred. Generally TCP, the data is transferred in the form of bytewise. So they are going to ensure that your data is received in the correct order, whatever the order required, and then they're also ensuring that no, there is no any chance the same data are sent duplicate time, more time, two times, three times, or some data may be lost. No. They're also ensuring that the error check means ki TCP check the checksum to detect either during the data transfer and transmitted the corrected data. So what the scenario when it's let's say 10 byte 1024 byte data transfer here happen. So before sending this data, they have find out the checksums of the validity and send data, and sender also apply the checksums, and both checksum are same. That means the data is same transfer, there is no any bit transfer, there is no any bit is disturbed. If something, some data are corrupted during the transformations are not received exactly the same which sender want to send, so what they are trying to resend data again. So they have a concept of the retransmitting data. If any data are corrupted or any data are lost or any either found while the transmitting data from the sender to receiver. Okay, and we TCP also ensure the control flow control as well as means ki, TCP regulate the amount of data sent at the times to prevent the network congestion. So network congestion means might be our sender are sending too much fast data and receivers are not able to receive a process to data as quick as. So what happened? Your our senders sending lots of data, receivers are not able to process so lots of bytes of data in the congestion in the network. So your network is better. So in this scenario, they have applied some flow checks and also added the congestion control. Means adjust the transmission rate based on the network conditions and to prevent the congestion. So what happened? This is sender sending a data here. Okay, so we have a apply some network bandwidth. How much network bandwidth we have? Okay, so according, let's see, our these networks are going to support 512 kilobyte per second. Here they are ensuring that the senders, whatever the big chunk of files, they are sending only those maintain rate so that the data is successfully transferred and here receiver can properly receive those. So here depend upon your network bandwidth, some bandwidth bit per second, byte per second, MB per second, KB per second. So whatever the plans, then because these the devices are communicated on your internet. So might be sender have a different internet bandwidth plan, consumer have a different bandwidth consumer plan. So might be a case. So we have to make the proper synchronization between the network of the two party. One is the sender, one is the receiver, and make the those control flow through which data is properly sender send and properly receiver receive with the help of proper internet utilization. You cannot say, hey, sender have a very high bandwidth speed, they can send a KB data, but our receiver, we have a very limited bandwidth capacity. They have only some, you can say, byte per second data can process. So you cannot set larger data to the sender. So all the communication between the sender and the receivers are properly managed with the help with the keep a point of your network bandwidth as well as. So they means our TCP protocol make the proper adjustment so that the congestion control flow properly maintained. So in this TCP, these are the basics, some components, or you can say architectures where they are maintained. How this communication happen. So here's first things we have to one the concept come under the socket. Socket is an endpoint for the communication between the two devices. It is an IP consist of IP address and port address. So whatever this is your system. So these systems and this is another system. Okay, so they want to talk to each other. So for talking might be noticed in your application lots of application running. Let's your window word running, ms paint running, some IntelliJ idea running, some server running. So generally in one computer multiple software is running. So your browser running, Google browser running, Chrome browser, from Chrome browsers or Google browsers, so lots of application running our system. So question is that, hey, sender sending to send data here, so which software are going to receive the request? So generally each and every applications is required the come first. This is the sender want to send data. The first sender must know where which device I am going to connect. So device means the IP addresses. In internet, every devices, if they are connected to the internet, we have one IP address. So IP address may be IPv4, IPv6, and apart from that, this IP address and particular this machines, one require the port number. Port number means on where my application running. Maybe port number can be 8080, your web server port. Similarly, 25, 23. Lots of dedicated port numbers. So for connecting for make a connection between the your sender and your receiver, so we have a socket. Socket means the combinations of your IP address plus your port number, so that the sender are properly connected with a particular application which you want. So socket means the location, are you can say socket is just endpoints are a situation where our client know this is the IP address and this is the port number. So those combined, you can say this is the one socket. So one computer or one device can have a multiple sockets, depend upon your hardware bandwidth, okay, of system configuration. So this is the one part very important whenever TCP communication going to happen. So between the sender and between receiver, one connection going to create it. That means from this socket to this socket, connection is established. Means ki this is the sender also have a IP address and port number. Here also have a IP number and port number. So both can be understand. Hey, this is I have to receive data from this IP address and port address. They are sending from this IP to this port. So during the connection are established between the sender and receiver via the socket. So and once the connection established, then we need a, because the sender can send data that's are maybe bigger in the file, bigger in the size. Okay, so we have required the TCP segment. The segment is on a packet of a data that is transmitted over the network. It's contain the header and the payload. So what happened? Let's I want to send 5 GB data. 5 GB data. Are you our net? Why we cannot send 5 GB data are and the completely one? Because our the networks plan which we have, what our network bandwidth, what we have, let's see, our networks can only send 5 KB data per second. Okay, per second. So we have a rate 5 KB. So that means our TCP say whatever the 5 GB data, I am going to make a packet of 5 KB, 5 KB, 5 KB, 5 KB, 5 KB. They make one segment, TCP segment, that contain your payload means actual data plus contain the header information. Header information contain this is the sequence number from where which lots of header. Header contain the extra information about the packet. Packet is come from the this source IP, this is the port, this is the header, this is the sequence number, this is the packet number, this is the packet size, this is the checksum. Lots of information your TCP segment header contain, and apart from that they have a payload. So those segment are going to transfer here, and that segment received by this. So next segment is sent by, so here TCP make the connection oriented. So connection is established between the socket to socket, and now segment of data transfer, and segment is data transfer. Then our receiver receive the segment, and the header contain this is the sequence number, order number, payload, everything. So accordingly, here on the receiver side, data is going to make the proper order. So again, TCP have a TCP header. TCP header is the way in the TCP communication header play very important role. The header contain the control informations such as a source IP, destination port and IP, sequence number, and checksums. Okay, so these header information, whatever the TCP data, TCP is sending data in the form of header. So they have a one header information and payload. Payload, whatever the actual data they are. Header contains like your control information, like from source IP and port, destination IP and port, sequence number, control flow, checksum, time to live. Lots of information they have contained. From this header, our receiver are going to is arrange the data in a particular order. They ensure that they any data are not corrupted due to the checksum, and if something problem, they have a request for the retransmit. and again they have a contain some sequence number, so that the sequence number are used to keep the track the order of data segment. Okay, acknowledgement number, this is a very very important. Whenever your client and your sender send data here, send data, and server receive your segment packet, they are going to the acknowledgement, hey, I receive the data segment with the sequence number this, that's are success or failure. Means ki they have a received correct order. Let's keep first segment 1 receive, then segment 2 receive, then segment 3 receive, 3 have a, and also check the checksum, properly checksum receive, also properly checksum receive. Any checksum feel, hey, this is a problem, so they inform the acknowledgement, success acknowledgement or failure acknowledgement or termination acknowledgement. So TCP communication is the very very kind of a well defined structure, you can say. Due to that, they are ensuring that data are properly transmitted in correct order without lost. So these are the basic components that we should aware in the form of. So let's understand how this communication happen between the source and destination, or senders and receiver. So first, as connection is established, first the whatever the devices they are going to communicate, device number one, device number two, whatever their devices. So this device also have make a connection. This is the IP address and the port. So socket to socket communication happen between the senders and receiver. So sender and receiver establish connection using the three-way handshaking. So here, client said, "Hey, sync," and who has a sync acknowledgement, then acknowledgement. So first say, "Hey, hello." This say, "Oh, yes," response. Okay, then so in this way, both are ensure that, hey, we are properly communication between device one to device two happen on the basis of sockets. Okay, once the communication happen, the second data transfer happen, then the sender send a data segment to the receiver. Generally data are sent in the part of your data segment. Data segment is a one particular TCP contain the header information plus the payload. Then thirds, if sender send data, then they are waiting for the acknowledgement. So receiver send acknowledgement to the particular segments they receive. And if any error detection, because the header contain the checksum of your payload, and receiver apply the checksum and check if everything okay or not. If check, receiver checks for the error and request retransmitted if necessary. If they found, hey, checksum is not missed, something fault happened, then they are going to the again request, hey sender, can you resend again. And finally, once all the data, whatever the data transfer happened, which like connection establishment happened, similarly now connection going to terminate it between the uh, devices. So sender and receivers are going to again make ensure that now are we going to terminate the connection. That way happen with a four-way handshaking. Hey, first saying, hey, client say, now I want to disconnect, close the connection, finish, you can say, then finish acknowledgement, then again acknowledgement. So look like a very standard protocol procedure follow between the device to communicate over the TCP channel. First your connection happen between sender and receiver as a socket IP and ports, and this is first handshaking happen between the client, hey, they say hello, they say okay, and acknowledgement happen. Once connection happen, then data sender send data, and receiver receive data and check every segment in a particular order. Each data are properly received, error check, apply checksum. If error happen, again said, hey, we need a retransmit this sequence number. Again, the sequence, the same sequence retransmitted. Every data transmitter, then properly connection going to terminate it. So these are the kind of high level flow where you can visualize, maybe send your particular laptop or receiver, maybe your server or web server, anything. So first they are going to say, hey, I am going to start the sync, means make a connection between the both. Then they receive the sync and send the sync plus acknowledgement. Hey, receive, hey, acknowledgement. So this is the sync plus acknowledgement receive. And after that, hey, they say, hey, I want to get this file. They send a request, and request is processed by something, and the server decided, hey, we have a request contain the some megabyte, right? They have sent one packet. Hey, you have received this packet, this bytes. They say it's okay, give the confirmation, yes, I received. Then next bytes are sent. Again, they can give confirmation, receive, yes. Again, send data, give confirmation. This. If all the data received done, then again going to the connection termination. Then similarly, like sync, similarly finish and connection finish and termination request is sent by the both party. So here you can say always if data are transmitted from anyone, both are going to the confirm yes data receive, yes data receive, yes data receive. If any data failure, data corrupted, again retransmission happen between the application. So this is between your mobile device, your laptop to the particular server. This is happen very fast. Even we as a application user or developer generally not visualize all this happen. Let's you say google.com and send some data. So you're not thinking something. All these things happen, but all these things happen between your mobiles to the Google server. So these are the some applications, maybe whatever the you can say web server or browsing, whatever the Google, Chrome, any browser you are using, generally they are it is TCP. Generally, all the website or web server, generally the browsers we are accessing, generally they are using the HTTP protocol. HTTP protocol is the TCP protocol. This is the communication between the web server and the browser happen within the TCP. So all these TCP protocols are maintained, are implemented by your web browsers and your server. Similarly, might be you receive the email maybe. So email is also use the SMTP protocol, simple mail transfer protocol. This is also use the TCP. All the communication between you are going to the open your mail, sending a mail, reading your mail. All this happen between the TCP protocol. Similarly, if you want to send some file transfer, maybe FTP protocol. Again, FTP also use the TCP protocol to communicate data. Maybe you want to access some remote machine, maybe using the SSH protocol, Telnet protocol. So these protocols also use your TCP. So many multiple uses of this TCP layer. And a good example, whatever the Googles are if you talk about the Google's use also TCP to communicate the data center and its client. Similarly, Amazon Web Services also using TCP communication between the cloud services and its client. Facebook's messaging platform also use the TCP to communicate its messaging platform to the client. All the online bankings also use the TCP communication. All the financial domains communication happen between the TCP. So these are the basics about the TCP. Similarly, let's understand the one of the also most famous uh, communication protocol is the user datagram packet. That means UDP. UDP is also kind of a transport layer protocol that's provide best effort connectionless communication between the two devices. So TCP provide the reliable and connection oriented. Here it is the connectionless and best effort to send data. So here it is designed for application that require fast, efficient, and reliable data transfer, but can tolerate some loss or corruptions of data. So this is the protocol is designed if some users, some applications are required very fast communication between the sender and receiver, and they are very efficient they want, and also ensure that the data reliability also they want. But data reliability can be sometime for some packet, some data may be can be lost, maybe not lost, but might be chances some data can be corrupted, some data can be lost. So if you are okay, such applications are okay, some frame of data, some packet of data may be lost or may be corrupted, still our application can work as expected. So those scenario, the UDP protocol help. But in the case of TCP are going to guarantee you we are going to reliable data transfer without any data loss. But here data loss can be possible. But is still nature of applications where some packet loss is manageable. So both protocol TCP and UDP both are used with the context of your nature of application. We will talk some example where the TTP also based. So as I mentioned, in the UDP, the connectionless. That means UDP does not establish connection between the devices before sending a data. It sends data just independently. So here, whatever the sender want to send data, okay, and the receiver, okay. So here, just they send our packet over the internet. They packet over internet, and then receiver receive the question is how receiver receive. There is no connection established before sending this the packet, the data they contain the information I want, this is my sender IP, this is my receiver IP. So our network routing or find out the proper route to communicate here. So each packets maybe follow the same route or maybe one follow different route to reach the destination. So here technology each the packet you are sending data packet to the that contain the sufficient information. Hey, this sender IP, this is the receiver IP, and this is the port I am going to communicate. So here, due to the data packets are sent by receiver, can follow different path to reach the destination. So it might be due to that there is some network congestion. Some data receive very fast, some data may be received very slow. So due to that, might be possible some data may be corrupted or some data may be lost. But in this way, our senders are sending data continuously. Due to that, they are very fast and they are very effective. So here they say the best effort delivery means UDP does not guarantee delivery of data packet. If any packet lost or corrupted, it is not the concept of retransmit. If some data are received by this sender and saying it is corrupted, so there is no concept again request hey sender can send this packet again, because here we want to meet the fast and efficient transmit of the data. We have not any make sense our data is the delay. Okay, if data is required at a time, if after why not retransmit, let's retransmit happen after some time you receive the next same data, but there is no any make sense because the time is over. There is no benefit to again get those data. The nature of like any live you are watching some cricket or mobile, some data lost, and after some time again you are sending the same packet, that is not make sense. So some scenario where live streaming, video calling, online something gaming happen where real time responses required. Their time is so matter. So in those scenario, this UDP is best effort delivery. And similarly, as we discussed, there is no any concept of kind of error checking, there is no concept of control check, there is no kind of congestion control. Because here there is not required any congestion because they are not make any pre established connections. So what the network bandwidth, if what the rate of the data we transfer, because In the UDP, each data packet can be follow the different route, different path. If this route is very congested, so the new packet would follow the different route. New data packet can follow different route. So due to that, there is no required of a control flow or error detections or error detection due to the timing constraint, because we want real time responses. There is no make sense to check error and request for retransmission. If you really want to reliable data, ensure data is not corrupted, then go for the TCP communication. If you want some data can be lost, but I want very fast, very quick, very real time response, then UDP connections is the very useful. And similarly, like in a case of TCP, similarly here also have a UDP socket. UDP socket is also an endpoint for the communication between two devices. It's considered again IP and port. Here also socket is same, but not make the pre connection between the particular IP and socket, particular IP and socket. Each data grams. Each data packet contain the receiver and sender IP reports, and according to the our router, find the particular routes and make connection a data transfer. Maybe after that, this data connection going to the close. Maybe next package, next connection establish and send data. So maybe each datagram packets found a different connection and different finally communication happen on the socket, but not the dedicated connection. UDP packet can follow the different route, different path, and reach the destination. And similarly, like in a TCP, we call the segment. Here's a datagram. Datagram is a packet of data that is transmitted over the networks, and it's contain the header and payload. Here also contain your header and payload. Header contain again source IP. Header contain your control information like source IP, destination IP, length, checksum, everything they contain, and the as well as the checksum. So checksum is to detect error in UDP header and payload. So every information contain your packets, and again the communications processing like first datagram packet created. Here, whatever our client or sender create one datagram packet and create the and just add the header and control information and send. Then there is no sending, just send an so datagram packet contain the complete information, source IP, destination IP, ports, everything, and the router or a gateway are deciding, hey, this packet want to transfer to which destination IP, and those packets are received maybe the different path. Then datagram transmission center send UDP datagram to over the networks, and networks here just sender send, hey, this is the packet, they contain every information and the payload. Hey, networks can you transfer? So according to the our uh, router decide, hey, this datagram going to the particular destination, which are the very fast and available path available, and they route the follow. And similarly, datagram receipt means the receiver receive the datagram packet and apply the checksum and everything. Datagram processing. A receiver process the UDP datagram packet and discard it if it is corrupted. If receiver receive different times different packet, and they decided, hey, something data corrupted, so they are not going to display. Instead of this, they are going to just drop them, and they are going to just display the fresh and new data. Due to that, say, hey, sometime some datagram packets can be discarded by the receiver, because while apply the checksum, he found, hey, this is the some bit corrupted happened during the transmission, right? So due to that, they're not going to apply the retransmission concept in the UDP. So this is the basic simple, you can say, the flow between your sender and receiver. Simply sender, or this is the receiver, send the data to the sender. Hey, receive request, yes. and they are responding data, different route they follow, receive here, receive here, receive here, receive here. There is any kind of either check or retransmit or something. Due to that, all the data, whatever response we have, each response are transmitted in the different route. Due to that, this becomes so fast and quickly real-time responses happen with the UDP protocol as well. So again, the same situation where these protocols are highly used, like online gaming. Now, multiple players are playing game. They are very important at the times. As quick the action is received by the player. The UDP is used the online gaming to reduce the latency, ensure fast and responsive gaming. Similarly, if you are doing any kind of video streaming, video call, so here UDP is the required, because video streaming provide the very fast, efficient, and reliable data transfer, right? And nowadays, all we are doing the VoIP calls, Skype call, Facebook call, WhatsApp call. So these voice over IP UDP required here, because they are not, we want to fast packet transfer. But there is not only specific dedicated connection required. Multiple connection, multiple route, multiple path follow, and each datagram packet as fast as received to the receiver, so that the data can be displayed. All the like similarly, your DNS also use the UDP to transmit, to resolve your host name with the IP address as fast, so that your applications are realized. Right? So lots of use cases where our communication between the client and the sender would, client and server would be as fast as then UDP protocols are used. And good example about, we talk about maybe all the video, social media like Netflix also use the UDP to stream the video content to its similarly YouTube also use the UDP to stream the video content to the user. Skype also use the UDP, provide the fast, efficient, and reliable voice communication or video communication. Google DNS also use the UDP, provide the fast, efficient, and reliable DNS services. So where the response required very fast, very efficient, the UDP is the required or very best fit protocol, right? So these are the commonly, you can say, nowadays TCP or UDP protocols are used to make the proper communication between the devices. So let's understand some normal differences communications. So major differences is that uh, here like whenever you talk the TCP, that means you want your all the packets, whatever the data you want to send, they are completely transfer here without any data loss. Even no data loss I want, every data must data completely data integrity and reliability. So here your TCP happened. Due to that, if they are ensuring every data are successfully fully transmitted to the between the party, between the devices. That will take some time to ensure the data transmitted. So due to that, this is not too fast compared to the UDP, because they require dedicated connection between the devices, and once message transfer, they need the acknowledgement. They receive success acknowledgement, then send the next data, again receive the acknowledgement, then send the, it will require time, because they offer reliable communication. They apply every error check, retransmission, congestion control flow, everything they had to check. Due to that, it will take some time. But the UDP is just sending message, sending message. If some data lost, no problem, this is going to discard it, no problem. So in this scenario, they are providing very fast and efficient communication between the data transfer. So overall, lots of points, but this is the high level, very fast, little bit slow compared to the UDP, but it's very, very reliable. No data loss. Here can be data loss. Okay, so some points maybe like here always required your three-way handshaking between the devices to make the proper connection, but here there is no connection required because the data is a sent individual datagram packet, simple, and they are not follow any dedicated connection between the sender and the receiver. They follow different route, different path to receive the uh, receiver. This is the guarantee to reliable data transfer using the sequence number, acknowledgement, retransmit. But this is there is no guarantee, you can say the data is transferred, but they are try to best effort how much data we can transfer. Even, but there is no concept of the packet loss or corrupted. In this case, there is no concept of retransmit. Okay, right? Similarly, might be here they regulate the amount of data to be sent at a one times so that they can maintain the control flow mechanisms like windowing, buffering, lots of concept here. But here there is no only concept of the amount of data because each datagram packets just divided them and sent. They are follow different route, different path to reach the destination. Here they required the adjustment of your transmission rate because they have dedicated connection, and according to the network bandwidth, network's rate, they have to adjust the sender and receiver's rate the way they are sent data, the way they are received the data. Like here, apply the congestion avoidance algorithm, congestion control algorithm, but here there is a no such transmission rate kind of things because whatever the particular route is free, they every follow the different route to reach the destination. Similarly, here they are guarantee every data are delivered in a particular correct order and sequence number. But here there is no such a guarantee. Maybe some packet deliver fast, some packets deliver delay. There is no correct order. Sometime up and down happen. But no. But objective is that fast delivery. Here objective is the ensure guaranteed delivery. Here, maybe this is generally TCP is slower than UDP due to the make established connection, error correction, the data correction. This is generally faster than TCP, but lack of communication or error detection. Sometimes you can also think the typically it is the header size is the very larger of the TCP because they have a maximum 20 byte of data as a header required, right? But here typically smaller header size than this TCP. There's only 8 bytes of header required. So this is also play a very significant role. Unnecessary 20 bytes of data you are transmitting every communication between sender and receiver, right? Due to the header always pass. So this is the extra bit of information you are transferring. Due to that, also it will become a slower, it's become a faster because they have a very less header size. They have a built-in mechanism for to handling the error, failure, transmission. There is no such kind of built-in error handling mechanism. Just only one. If any packet lost or corrupted, they are going to discard it. And they are also ensure the data integrity due to the checksum, and there is no such data integrity concept, but they are trying to best effort to fit. Okay, and they are typically very a higher latency compared to the UDP. UDP is a very lower latency. Lower latency means quickly the data is transferred from sender to receiver. Here it will take due to the acknowledgement, due to the error check, due to the error congestion control mechanism. Okay, so lots of maybe here the lower throughput. Here is a very higher throughput, you can say, due to the UDP is the very not so much extra works. And similarly, here bandwidth adjustment can be applied. There is a no bandwidth adjustment can we need to apply. So lots of points have, but I'm not going to cover everything. But overall, high objective is that uh, depend upon your simple use case. So whatever the suitable application you have to test. So some where all the financial application, banking, or all the web browsing, email, file transfer, data transfer, we are ensuring that the data must reach. It will take time, no problem, but we want ensure the complete data is transmitted, no single bits are lost. But here, suitable applications are we required very fast and efficient within a time data. Not so we have a very time meter application like video calling. If you are doing video callings, live data must be displayed. That makes sense. If you are video calling and your data packet transfer delay, that not make a good experience or user experience, you can say. The nature of applications, so here maybe online gaming, video calling, wife calling, whatever the callings where the timing is very matter. If the particular data are come on the particular times, it's, let's see, online game is going on now online, let's say cricket, streaming going on. Let's say one ball is something stump out, and that are the corrupted data. So you can say, hey, data corrupted, and going to again resend, and again after some time again say, hey, now you are displaying ball is out or something. That not make sense because the time is over. So where the timing is very important. Without time is the value with the only times. If particular data is not on the time, there is a no value after some times, after later times. So those applications where the particular data is only valid a particular time, so UDP is the best. Here say timing can be, but I want to issue data, not more matter. This data always would be the required. Maybe after 5 minutes, 1 minute, 2 minute, millisecond, no problem. So this is the nature of application. This protocol TCP or UDP we have to sell. This is the gist between these two protocols. Okay, so these are the basics about this TCP and UDP protocol. TCP depend on nature of your applications, where you want data must be transferred. Data is valid for the period of times, or always the times. But UDP required where the data packet is only valid, only valuable after on the particular times. After those time elapse, this data are useless. There is a no problem. There is not a benefit. So those scenario UDP. So UDP required best effort connection protocol provide the very fast, efficient, and reliable data, and can tolerate some data can be discarded if they are not corrupted. But TCP is required where the data is always guaranteed. So reliable connection oriented protocol ensure that guarantee that your data is successfully delivered to the customer. So choice between the TCP and UDP or depend upon your requirement or your application use case. So both, you cannot say this is the TCP is a good protocol or UDP is a not good protocol or bad protocol. Both have the very good edge points, and depend upon our application use case scenario. Whenever your system designing, you have to mention here we have to make connection between the two devices, yeah, two services, use a TCP connection or UDP connection. You should aware why we need a TCP, why need a UDP, because the different for different use case, different scenario, different situation, these protocols are placed. These protocols are heavily used. We should aware as a system design engineer, hey, where we can apply here TCP connection, when we can apply for the UDP connection. So that's for the day. Hope this information is helpful for you. Thank you.